All right, guys, today we're going to talk about graphing. So in our notebooks, we're going to add page 77 for now. We might add more tomorrow. We'll see how this goes. So we're going to talk today about graphing, square roots, and cube roots. So we're only doing those two. We don't have to worry about all the other funky roots. And you should have something like this. And for now, I'm just going to fold it in half because we do need both. And we'll put this on 77. I want to leave 78 open just in case we want to do a little bit more graphing practice. Let's kind of wait and see. Okay, so 77 right here. And just on the front, I'm going to remind us what this is about. So graphing square roots, so y equals square root of x, and cube roots, like this. Now these are the most basic form of that function. And again, as always, it's super helpful to go do our little graphing lab. So if you haven't done that, I would suggest doing that so that we can see how all the things will change what my graph looks like. Now, the shape of this graph here is kind of going to be a shape like this. So I don't know, kind of a hook sort of looking thing. And our cube root is going to have sort of a shape that looks like this. So like a stretched out S sort of thing. So those are their general shapes. They're always going to look like that. But if I do some stuff to the equation, like add, subtract, multiply, whatever, it will slightly adjust that. Okay, so that's what we're looking at in our little lab. So first we have our square root function. The shape, like I said, is kind of this hook thing. If there's an a out front, as always, a is kind of like my slope, but slope in quotes because we can only do it once. And we're going to do it rise over 1. So all the usual rules for slope we want to keep in mind here. H, notice that H is under the root. So it's kind of like in parentheses, sort of. H is always my opposite number, and it's moving us left or right, but opposite. And then K is outside the root, and K is always moving me up and down. And then kind of together, the H and the K get us this really nice starting point here. And then we use our slope to get one more point to figure out like how steep this graph is right here. So like a over 1 is something like that. Now the domain and range for this graph is really unique because this graph typically is pointing in only 2 directions. So like the general shape of this graph is kind of up and right. So for the most part, unless crazy negatives get involved, my range, or excuse me, my domain are all the x values, and x is going right, so we're going to be greater than or equal to. Now this can change with a negative, and then it'll always be the h value, whatever that is, or the x value right here. And then range is going to be y is greater than or equal to. Again, greater than or equal to because we're up, but it could change because of a negative. K, because k is my y value. Okay, so, and again, like as long as we know how to graph, domain and range should be easy to find. It's like looking at this one here. My a value is 1. My h and k is 1, 0. So we're going to start at 1, 0, and then we're going to do a slope of 1. So I go 1, 0 right here. I do my slope of up 1 over 1. We do not go in multiple directions. We're just going to do the hook now. So it kind of looks like that. Because there were no negatives involved, x is going to be greater than or equal to 1 for range, or domain, my goodness. And then range will be greater than or equal to 0, because again, no negatives involved. Let's change the second one slightly. Let's get a negative up in there. Let's make this a -2. Okay, so my slope is -2. My h and k is going to be -1, -4. So that's going to be my starting point. And then we're going to do our slope of -2. So we go -1, -4 to start right here. Still a square root. So now we're going to do our slope of down 2, forward 1. And so now my hook has kind of been reflected down. Okay, so now it's kind of hooking in the opposite direction. So we're still going to the right. So x is still greater than or equal to -1. Like your domain will change if inside changes to a negative, which usually you won't see that. But if the outside changes and you're changing up and down stuff, so because the y is negative or we're going down, we're going to be less than or equal to -4. Okay, we also took a look at cube root functions. So the shape of a cube root kind of has this starting point, and then we do like a stretched out S sort of shape. We have our a, h, and k like always. So a is going to be my slope. Ooh, maybe I should specify. For like our square root function, once rise over 1 and also one direction. Like it really only, you can't go both directions from your starting point. You only go in the one direction. So a over here is still slope. It's still only done once. It's still rise over 1, but this one can go in both directions. And that's because this S shape goes in both directions. Like the hook only goes in one direction. So that's what I mean by, well, RIP. Well, I mean, they're alive, but like they're just not together anymore. It's just Harry. It's Harry. Anyways, H is still left and right movement, and it's opposite of what we see. So inside is always opposite. And then K is our up and down movement, and K always stays the same. Now, the interesting thing about domain and range here, this graph will always point left and right. So that's all. And as slowly as it's still going down this way and up slowly that way. So it's always going up and down. So it's all. So cube root, domain and range, real easy, all, always all. Okay, so we have a cube root function, which means we're going to have an S shape. My starting point here is -2, -1, and my slope is 1. Domain and range is easy, always all. Okay, so we can do our starting point. So -2, -1. And then I can do my slope in both directions, so up 1 over 1, and down 1, back 1. And then we kind of just need to make it look like a stretchy S. Make sure we're curvy and we're not doing like line things. Okay. I still have a cube root function, so we're still going to be an S-shaped thing. My starting point will be 3, 2. My slope is -1/3. I wish I would have made us like not a 10 by 10 graph here. -1/3 is real small. Domain and range is all in all. So we're going to start at 3, 2. So when my slope here is -1/3, I'm going to go down 1/3. So just an eensy bit, and then over 1. And then I'm also going to go up 1/3 and backwards 1. So like, this S is like a flipped backwards S. But so tiny. That's kind of hard to do. Do you see how it's flipped backwards though? It's like, boop, like, whoop. Anyways, a couple quick ones. We might add more to this if we need to tomorrow. So I'll see you in the next one. Oh my gosh, if I can hit stop.